Okay, this is part 2 of angles for the beginning of the trig unit for advanced functions. The next thing we're going to talk about is radians, and I think this is a new concept for most, if not all of you. But here's the idea. There's this thing called the unit circle, which if you go on to take pre-cal or anything like that, you'll likely see again. But there's this thing called the unit circle. So I'm going to try to draw a decent circle here. That's all right. And the idea here is that it's called the unit circle because uni, means 1. This is a circle with a radius of 1. And before, we talked about it being 360 degrees around. But let's actually think about the distance around. Okay, we call the distance around the edge of a circle the circumference. And if you remember, the formula for circumference is 2 pi r. Well, for this unit circle where the radius is 1, you would just plug in 1 for r. So your circumference is 2 pi, meaning the distance all the way around. So if we start from here at 0, and then you go all the way around the circle, when you got back here, it would be 2 pi. Okay, so again, what I'm saying is that if we started here and traveled all the way around the circle, that distance would be a distance of 2 pi, because that's our circumference. That's the distance around the circle. Okay, now before we had 0 and 360 right there, because it was 360 degrees around. So now we're changing it, we're calling it 2 pi. This is just a different way to measure. It's still the same process, same idea. So we got to split this into 4 pieces though. So instead of 90 degrees up top, this is now going to be 1/2 pi, or pi over 2, because that's just 2 pi divided by 4. And then this over here is going to be pi. And this down here is going to be 3 pi over 2, or that's the same as 3/2 times pi. Now these are still the same thing as 90 degrees, 180 degrees, 270 degrees, and then 360 degrees, and so on. But we're going to talk about it in terms of radians now instead of in terms of degrees. So the first thing you really need to know how to do with these radians is to convert from degrees to radians and vice versa. So let's look at a problem with that. Let's convert from degrees to radians. So first, let's do that with 30 degrees. Okay, well, think about unit conversion just like you've done in physics or chemistry or anything like that before. We need to find some relationship. Like, let me just give an example over here to the side. Let's say you had, I don't know, 10 feet and you wanted to change it into yards. You would multiply this by 1 yard over 3 feet. Okay, because this fraction is really just 1, because 1 yard and 3 feet are the same thing. They're the same distance, the same length. And the reason I put 3 feet on the bottom is because I want the feet to be able to cancel out. So the key is to have a fraction that shows the relationship between the two distances. By the way, this would be 10 thirds, 10 yards, 10 times 1 on top, then just the 3 on the bottom. So you have to find a relationship between the two distances where they're equal, and you make a fraction out of it. Then you make sure you put on the bottom the unit you want to disappear. So let's look back here at my unit circle. Okay, the one that's most commonly used is actually right here. Okay, pi and 180 are the same thing. You can use 2 pi and 360 if you want to, but they're really just reducing the fraction. I mean, if you think about it, 2 pi over 360, I'm just reducing the top and the bottom by 2, and it gives me pi over 180. Okay, so we're going to use pi over 180 in this case, because pi is halfway around the circle, so pi radians, just like 180 degrees is halfway around the circle. I'm sorry, there shouldn't be an equals there. We're multiplying this. So we end up with this. Now if it helps you, you can put a 1 on the bottom, because that's really what's going on here is we have 30 over 1. So the degrees cancel each other out. Again, whatever you want to cancel out needs to go on the bottom. And then I get, just multiply across 30 pi radians over 180. Okay, let me erase this example here. And then I can reduce that. 30 will go into 30 and 180, so this reduces to pi over 6 radians. So 30 degrees is the exact same thing as pi over 6 radians. Okay, so now let's look at another example. Let's do 90 degrees. Okay, I'm trying to go from degrees to radians, and the way they relate is pi radians is the same as 180 degrees. Gives us that. So we can cancel out the degrees. And if you want, you can go ahead and do some simplifying here, because this is just 90 over 1. So both the 90 and the 180 are divisible by 90. So you get this. So on top you have 1 times pi, which is just pi. On the bottom you just have 2. So it's pi over 2 radians, which if you looked back at the circle we drew, you could have seen that already. But 90 degrees is the same as pi over 2 radians. So if you notice, for all of these, all I'm doing is multiplying by pi over 180 and then just simplifying the fractions. Okay, let's try one more going this direction. 135 degrees times pi radians over 180. 180 degrees. The degrees cancel out, and we get 135 pi radians over 180 degrees. Oh, sorry, messed that up. 135 pi radians, and degrees are gone, so we just have 180. Alright, so we need to think about what these are divisible by. I think they're both divisible by 15, if I'm not mistaken. Actually, 45. They're both divisible by 45. So that would become 4, and that would become 3. So we get negative 3 pi over 4 radians. Okay, now you can do this in your calculator. Let me briefly show you that. For one thing, let's just say you weren't sure how to reduce. Remember, this one was 135, or actually negative 135 over 180. So if you plug that in the calculator, and then just change that to a fraction, it does that reducing for you. So you can do it that way. Sometimes they may just ask you to do it in the calculator and ask you to just give it out to 2 decimal places. So for this one we just did, it would have been negative 135 times pi divided by 180. Okay, please don't use 3.14 for pi. Use the real number pi. So we get negative 2.35 for 2.36 if we rounded to 2 decimal places. So they may ask you sometimes to do it in your calculator, and that is how that would be done. Okay, now let's go the opposite direction. This was from degrees to radians. Now let's go from radians to degrees. Okay, so convert from radians to degrees. Okay, so the first example we're going to do is pi over 3 radians. Looking in the wrong spot. Pi over 3 radians. Okay, now this time we're trying to cancel out the radians. So instead of doing pi over 180 degrees, we're going to do 180 degrees over pi radians. Okay, so hopefully that makes sense. We just flip the fraction. These are still equal. 180 degrees and pi are still the same thing, but we just flip the fraction so that we can cancel out the radians. So if you notice, we can also cancel out the pi. So that just leaves us with 180 degrees on top and 3 on the bottom. So that is 60 degrees. Okay, so second one, let's do negative 5 pi over 3 radians. We want to go from radians to degrees, so I put the degrees on top, 180 over pi radians. Okay, so the radians cancel out, the pi's cancel out, and I get negative 5 times 180 on top, and I get 3 on the bottom. Okay, you can go ahead, you can do this in just about any order at this point. I'm going to go ahead and cancel out the 3 and make that 60. Negative 5 times 60 would be negative 300 degrees. So negative 5 pi over 3 radians is the same as negative 300 degrees. Okay, last one, we'll do 1 radian. multiply by 180 degrees over pi radian. The radians cancel out. If it helps, you can make this original a fraction. It's just 1 over 1. The radians cancel out. We cannot cancel out any pi's this time. So all we're going to end up with, since there's just 1 over there, is 180 degrees over pi. Alright, so that's converting from radians to degrees. Now, there's one more thing we need to talk about, and that's how to find the length of a circular arc, or how to find arc length. So actually, let's go back, look at this picture again. The blue I drew was to illustrate the circumference. The circumference is the distance all the way around the circle. Arc length is just a distance part way around. So an arc length might be from here to here, or from here all the way around to here, or any piece or part of the circle. So arc length is just saying one arc, one curved part, one part around the circle. That's the key. Okay, so there's a formula for finding arc length. And that is S equals R times theta. Now this looks like a 0 with a line through it. It's a Greek letter called theta, T-H-E-T-A. Okay, so first of all, we need to know what these things represent. S is the arc length. R is the radius. And theta is the angle, but it must be in radians. Okay, this only works if we're in radians. Believe it or not, if we're in degrees, this is actually a much more complex equation we have to do. So it's simpler if we have it just in radians. So S is the arc length, R is the radius of the circle, and then the angle is there, and it has to be in radians. Okay, I did paste a picture up here to kind of help you see what this looks like, so you get an idea. That red piece of that circle again is the arc length, S. R is the radius, that's the distance from the center to the edge, and then theta is the angle. So let's do a couple examples with this. We're going to be using the equation S equals R times theta for all of these. So first, given a circle with a radius of 3, what is the length of the arc intercepted by the angle pi over 3? So our equation is S equals R theta, and they want us to find the arc. It says, what is the length of the arc? So S is what we're searching for, so I'll just rewrite S, because that's what we're looking for. The radius is 3, so I'll plug 3 in for R. And theta is pi over 3, so I plug that in there. Well, 3 times pi over 3, the 3's just cancel, and we get pi. So the length of that is pi. Our arc length is pi. Okay, so hopefully you see it's pretty simple. They're going to give you 2 pieces. You got to find the third. It's really just plug and chug. Okay, next one, find the angle that intercepts an arc with length 5 on a circle with a radius of 10. Alright, so this time we're not looking for the arc length. We're looking for the angle. So we're trying to solve for theta this time. So the arc is of length 5. The radius is 10. And we have to solve for theta. So we divide both sides by 10. We get 5 over 10 equals theta. So theta is equal to 1/2 radians. Okay, so now we know we can solve for something other than S if we have to. So as hard as this is going to get is something like this. It says a circle has a radius of 10 inches. Go ahead and write the equation here. Find the length of the arc intercepted by 120 degrees. Now if you remember, I said this only works if you're in radians. So we have the radius we can plug in here, but we cannot plug 120 in for theta because it's degrees, and we need radians. So we've got to convert this. So 120 degrees times pi radians over 180 degrees. Okay? So the degrees will cancel. 120, 180 are both divisible by 60. Sorry, so this would be 3. This would be 2. So we end up with 2 pi on top and 3 on the bottom, and that's radians, which is what we needed. So we would plug in 2 pi over 3 right here. So I want to say this again, make sure it makes sense. This equation, s equals r theta, is only good, it only works if we are in radians. So when they gave us 120 degrees, we had to convert that to radians to make it work. So then just do 10 times 2 pi over 3, which will be 20 pi over 3. Now I know this is a whole lot to do with angles, but a good bit of it should have been reviewed from geometry and other classes, so hopefully you're with it. What I would suggest to you is to go to your book for some practice and look at page 450 to 451. Anything 1 through 68 is a good idea. I would encourage you to try the odds and check those in the back. Obviously, if there's homework assigned in class, make sure you do that.